This is video 1 from Unit 10, Lesson 1. We're going to talk about rational functions, and in this lesson we're going to look at simplifying. Okay. So these are examples of rational expressions. So 1 over x, that's like our most basic. So rational expressions are fractions. They're fractions with variables in them. Something I want to note, most of the functions that we've looked at so far have just normal domains, like you can put anything in for x, so we would say all real numbers. But rationals are different. So if you have an x in the denominator, we can't have a denominator that equals 0. So for 1 over x, I could say that the domain is all real numbers except where x is equal to 0, because I can't do 1 divided by 0. And here, it would be x can't equal what would give me a 0, and that would be -4, because -4 plus 4 is 0. And then so for this one, x can't equal 2. So it's just something to note, like especially as we start solving these. Okay, so when we're just simplifying, these are our steps. We want to factor the numerator and denominator, if possible, and cancel out common factors. So when you just have single terms in the numerator and denominator like this one, then there's nothing that you can factor out. But I do have common terms because I have an x on the top and an x squared on the bottom. So I can cancel these. So x over x squared would be 1 over x. So the x cancels in the top and 1x cancels in the bottom. So this simplifies to 1 over 2x. Okay, for this one, factor the numerator and denominator. So I can factor a 6 out of the top. So that's distributive property backwards. And then I have x plus 12 on the bottom. Okay, well, if this had been x plus 2 on the bottom, then I could cancel. So like if originally this had been x plus 2, and then this is x plus 2, I could cancel these x plus 2's, and I would just be left with 6 as my answer. However, it's not. So this is all I can do. I cannot cancel these x's because they're attached to this plus sign. So if you have a plus or a minus sign in a numerator or a denominator, then they have invisible parentheses around them. Now these have parentheses, so those obviously aren't invisible, but down here, if they have a plus or a minus, they have invisible parentheses around them. So I could have done that up here as well. And so I can't cancel out those x's. I also can't cancel out the 6 and the 12 because of these parentheses too. Okay, so let's do a few more examples. Okay, so you just have single terms, so nothing to factor. Your 4 and your 6 can reduce to 2 over 3. And then your a squared over a can get an a over 1. So you're left with 2a on top and 3 on bottom. Okay, over here, all 7 of your x's will cancel on top, and you're left with 2 on bottom because you'll cancel 7 out of those 9. So if your whole numerator cancels, then that means you just have a 1. And x squared on bottom. Okay, here, I have an expression, meaning I have a plus or a minus, so I see if I can factor. There's a common factor of 4. X plus 3 over 8. And since the 4 is outside these parentheses, you can cancel with the 8. So you have x plus 3 on top. over 2. And it's fine if you put those parentheses there. Okay? Next problem. It looks like I can cancel out a 3, or factor out a 3 from the top. And then since this 3 is outside, I can cancel with the 6. So x minus 3 over 2. Okay, let's look at a few more. A plus 5 on top, nothing can factor out. I don't have a common factor, but on the bottom, I have a common factor of 2. Okay, well, I can cancel this whole a plus 5 because I have a whole a plus 5 here. So my whole numerator cancels, which means I have a 1, and then I just have a 2 on the bottom. Okay, nothing can be factored out of y minus 6. Now if I notice the denominator, I don't have a common factor, but it is a special case. Y squared and 36 are both perfect squares. So remember when we factored these were difference of squares. So it factors to 2 parentheses, y and y, and then the square root of 36 is 6 and 6. 1 is plus, 1 is minus. So now I can cancel out the y minus 6's, and I'm left with 1 over y plus 6. Okay, not a common factor to take out of the numerator. Not a common factor to take out of the denominator, but it's a trinomial, a quadratic, so there's an x squared trinomial, so it factors to 2 parentheses. So the first 2 numbers are x and x. The last 2 numbers have to multiply to be 14, and then add to be 9. So 2 and 7 goes positive. Okay? So your x plus 7's can cancel, and you're left with 1 over x plus 2. Okay? Now 8, this is a little tricky. So 3x plus 7 and 3x minus 7. Those obviously aren't the same. But they're really close. They're really close. And there's no common factor. The x is not a quadratic, so it doesn't factor to 2 parentheses. So what you can try to do is take out a negative 1 from the denominator and see if that gives you the same. And it doesn't, so this one is done. Okay, if they weren't the same, but they were the exact opposite, so if this were just another example, if they were 3x plus 7 over negative 3x minus 7, then, so they're not the same, but they're the exact opposite. So 3x plus 7 was negative 3x minus 7. Then you could factor out that negative 1, and my answer would just be negative 1. But these were not the exact opposite because your 3 stayed positive. So this one was already done. So this is simplified as much as you can. Okay, so let's look at Unit 10, Assignment 1.